All right, so we're going to take a look at section 5.4, which is on conjunctions, disjunctions, and combining inequalities. All right, so a lot of the stuff that you guys already have done, that's most of the section. We just have to add a couple things to it, and this is it for the week. So once we get through this section, we're done.
Mr. Roy.
All right.
Glad you could join us.
Thanks, man.
So two special things we're going to look at with inequalities. The first one's a conjunction. Okay. Does anybody know what a conjunction is? Even from English, like what word is a conjunction? When it's a word used to connect two ideas, two things. Yep. So it's a single word.
Is it and?
And. Yeah, and is a conjunction. Okay, so on your notes, okay, you want to write down a conjunction. It's two sentences, okay, connected by the word and. Okay, and remember, in math, when we talk about a sentence, it doesn't have to be, like a sentence you'd have in English. Okay? This is a sentence in math. X is less than 2. Right? So it's two mathematical sentences, just like that, connected by the word and.
Guys, those are like the quotation marks and the parentheses. Don't worry about that, okay?
But that doesn't go here.
I just put
Yeah, what you want, right next to that first bullet, you're going to write what it says right there. Composed of two sentences connected by the word and. If you wrote something like Logan said he wrote and in the parentheses, that's okay. I'm saying you don't have. That's something Mr. Hager and I did last year, and we're going to get to what that means a little bit later. So don't worry about that right now. As long as you get right next to that first bullet, composed of two sentences connected by the word and, you're in good shape. Now we're going to get to the next bullet right now.
And for a conjunction to be true, okay, both sentences have to be true. All right, so let me give you guys a conjunction in real life. Okay, not a mathematical conjunction. Okay, that's true. Okay. We're in the month of December, and it is Wednesday.
That's the same thing as Hager.
Yeah.
Where's the snow? That's what I want to know.
There's no snow yet.
Always comes up.
All right, so we're in the month of December, and it is Wednesday. Okay, so you look at the first sentence I said. We're in the month of December. Is that true? Yeah, that's true. The second sentence I said, it is Wednesday. Is that true? Yes. Okay, so that whole statement that I just said, that conjunction, it is true. The first part and the second part were both true. Now, if I said something like, we are in the month of December, and it is Monday, well, that's false. The first part was true. We are in the month of December, but the second part, it's Monday, that's false. Okay, so for a conjunction to be true, both sentences have to be true. All right, another example, is anybody into computers at all? Maybe in infotech?
No, thank you.
No? Well, in computers, they use the word and a lot. Okay, if you think of a website you go to where you have to type in, say, a username, and you have to type in a password. In order for you to be able to log into your account, which one of them has to be correct? The password? Or the username? What about that? Does the username have to be right? Yeah. So on a computer, that's what we call an and. You have to type the username right, and you have to type the password right to get into your account. If you type the password wrong, but the username is right, no good. If you type the username right, but you get the password wrong, no good. You got to get both of them correct to get into your account. All right, so that's in the programming of the computer or the website, they use the word and. They have to make sure both are correct. Yeah?
May I go to the bathroom?
Yeah. All right. And the other special word we're going to talk about with inequalities, does anybody know what the other one is besides a conjunction? Yeah, we have a disjunction. Right, so a disjunction, okay, is two sentences, but this time they're connected by the word or. All right, so there's a big difference between the word and the word or. Okay, what is that? What does or mean versus and? Yeah?
Or means like one or the other.
Yeah, and means definitely both. Okay, like if I said you're going to have homework Wednesday night and Thursday night, it means you're going to have homework both nights. The word or can be a little tricky. We can interpret it different ways. All right? It can mean one or the other, or sometimes it means both. Okay? So it depends on how we think about it. So if I said to you, you're going to have homework Wednesday night or Thursday night, okay, I think most people would interpret that to mean one of the two nights. He's either going to give us homework Wednesday or Thursday, but not both nights. All right? And that's generally, in this class, how we're going to view the word or. Okay? So for a disjunction to be true, you only need one of the two sentences to be true, at least one. All right, so if I, let's say I said this, it is December, or it is Monday. Is at least one of the things I just said true?
December.
Yeah, it is December. That part was true. And for a disjunction to be true, you only need at least one of them to be true. Okay, at least one. What if I said it is January or it is Monday? Is either part of that true?
No.
No. So that disjunction is false. I didn't have at least one part that was true. But what if I said it is Wednesday or it is January? Is that true? Yes. All right. For an or, you just have to have at least one part that's true. Okay. Another way you could think of an or is pretend like you worked at a company and there was like a door you had to go through, like a security door. And it said on the door, you either have to take and insert your card or put down your thumbprint. Okay. Would you have to do both, or would you just have to do one of them?
You said or.
Yeah, I said or, so would you just do one of them? Either put your card in the door or put your thumb on the keypad. Okay, you only have to do one. Now, if it said and, insert your card and put down your thumbprint, would you have to do one or would you have to do both? If it says and, you got to do both. Okay, both of them at the same time. All right, so that's the main difference between a conjunction and a disjunction. Conjunction is and, you got to do both. Disjunction is or. You just have to have at least one. Okay, so any question on conjunction or disjunction? All right, so these two symbols that we've been using, this one and this one, somebody tell me, how do you pronounce this?
Less than or equal to.
Say it one more time.
Less than or equal to.
Less than or equal to. Okay, he just used the word or. How about this one?
Greater than or equal to.
Greater than or equal to. So if he pronounces this with the word or, which is correct, what does that mean this is? Is that a conjunction or a disjunction? That's a disjunction. Okay? These two symbols that we've been using are disjunctions. Okay? So if you look at this, this is how you pronounce it. X is less than or equal to 2. It's either less than 2 or it could be equal to 2. So it's a disjunction. We really haven't mentioned that, but that's what it is. Same Same with greater than or equal to. That's a disjunction. It could be greater than, or it could be equal to 2. Either one. Doesn't matter. Right, so what we're going to do is we're going to practice graphing a disjunction, and it's really going to feel like the same thing we've been doing. Right, so you know how you guys on the homework, you didn't have a lot of these equal to symbols? Like pretty much every problem was either a less than or a greater than. Well, we're going to do the same thing we've been doing, and that's why I had you guys practice in the warm-up doing a filled-in circle. All right? So let's practice graphing this. Right? So this is a disjunction because of that symbol right there. Right? But we're going to go through it just like we've done before. Okay? In fact, I think in the homework I even changed one just to practice a filled-in circle. All right? So who can tell me what's my first step? Right?
Got 11 to the other side.
Yep. And how do you get 11 on the other side?
Subtract it.
Perfect.
Both sides.
Yep. And subtract it. Okay, now on the left-hand side, I've got negative 3x. Okay, Alex, what's 26 minus 11? You got 15. Okay, now the big question. Do we flip the sign? Corey?
Yeah.
Okay, why do you flip it?
We divided by, or we subtracted by. Actually, we're gonna end up dividing by a negative, but not yet. We're not gonna flip the sign yet.
Yes, we're not going to flip the sign yet. Good catch. All right, we subtracted both 11 on both sides, but with subtraction, we never flipped the sign. Now, Corey's already on the right idea. We are going to end up dividing both sides by a negative, so we'll deal with that. Kevin, what's our next step to get x by itself?
Divide by negative 3.
Perfect. Divide by negative 3. Divide by negative 3. The 3's cancel. The negatives cancel. And Victor, what's on the left side?
Just x.
Just x. And tell me what's on the right side?
15 over negative 3.
15. Yeah, 15 over negative 3, which becomes
Isn't it 4? I don't know. Negative 5.
yeah, negative 5. Okay, and last step, should we flip the sign? Yes. Look at what we divided by. Okay, negative 3. Okay, so that's a disjunction. X is greater than or equal to negative 5.
Guys, that was the first example on the front side of your note sheet.
All right, so now when you set up your number line, you could go by 5s. Okay, we did that before, and that seemed to work fine, so let's do that here. Go 0, 5, negative 5. If you want to go by 1s, 1, 2, 3, 4, 5, looks like we got enough room to do that too. All right, how about Zach? What do I do next?
Put a closed circle on negative 5.
Perfect. We're going to put a closed circle on negative 5. And my last step, about Gabe, what's my last step?
Shading to the right.
Yeah, we're going to shade to the right because that's the way the arrow points. Good.
Mr. Hager, for the on that number line, when you like label it, would you have been okay with doing the number above negative 5 and below negative 5? Would you have been okay with that? Say we put negative 6, negative 5, negative 4. Would you have been okay with that?
Oh yeah, that's fine too.
Okay.
Yeah. So you guys can.
I know a lot of you
yeah.
guys have been doing that way. I know you guys like, oh. However you want to label a number line is perfectly fine, right? Mr. Hager went by 5s. If you want to do negative 6, negative 5, -4. I know a lot of you guys have been looking at your homework, a lot of you guys have been doing it that way. If you wanted to do 0, -1, -2, -3, -4, -5, you could do that too.
Yeah, as long as you guys are consistent. So like if you did something like this, 0, 1, 7, I'd be like, wait a minute, what? You got to just pick a method and be consistent. So if you're going to go by ones, go ahead and go by ones. But don't go by ones and then go by something different. Does everyone see what we mean? All right. But as long as you're consistent, you can label your number line any way you want. Yeah. Okay, so any questions on 1A?
And yeah, that's like Mr. Hager said when we first started doing it. That's stuff we've done, kind of looks what we did yesterday.
On the test, how many questions will there be?
Probably, since a lot of these are quick graphing ones, there might be a few more, but it'll definitely, probably between 16 and 17 problems.
Right.
16, 18, somewhere in that range. I think Mr. Roy and I still have to look at the test,
Yeah, good comment.
but we'll look at that.
Good question.
All right, example 1B. Yep.
Is it only if you divide by a negative you flip the sign, or is it multiplication?
It's multiplication too. Yep. Multiplication and division. You gotta, if you divide by a negative, multiply by a negative, flip that sign.
What about subtraction? Yes, no? No. You can subtract. Okay. Multiply and divide. Those are the two.
All right, so speaking of subtraction, what's my first step here? Logan?
Subtract 1 from 7.
Subtract 1 from?
Oh, 1 and 7.
Yep. So I get 2y. 7 take away 1 gives me 6. Mr. Roy just went over this. Flip the sign here or not? No. Okay, and Michaela, I know you weren't here, but you think you can get y by itself, getting rid of that 2? Yep, we're going to divide by 2. So that leaves y by itself on the left. Gauge, what's 6 divided by 2? 3. And look at what I divided by. Victor, should I flip the sign? No. Divided by a positive number. Okay, so that's the solve part. Okay, we got y by itself. And let's make our number line. Okay, why don't somebody tell me how I should do my number line? You tell me what numbers you want to put, and there's a lot of ways you can do this. Yep.
You put a closed circle on 3.
All right, how do I number it though? Because I don't know where 3 is yet. But I like the idea of a closed circle.
In the middle, you can put 3.
Okay.
And then in front of that, put 2.
And when you say in front, which way do you mean?
To the left,
To the left?
put 2, and then to the right, put 4.
Yep, that's good. And now you already told me what kind of circle. Just remind me again.
Closed circle.
Closed circle.
And then you shade it to the left.
And then shade to the left, because that's the way it's pointing. Perfect. Good. Okay. Any questions on that? All right, so this is one type of OR, okay? And it's basically an OR where it's built into the inequality. Other kinds of problems we're going to look at actually have the word OR written in it, all right? Not this symbol. So Mr. Roy is going to take a look at some different cases you can have with OR.
Did you guys have that? So you guys have this on your sheet, graphing disjunctions. We already talked about that when we know that they're OR problems. Now, like Mr. Hager said, when it has an OR in it, you have to think of it like almost like you're graphing two separate inequalities. All right. So once we start talking about this a little bit more, it'll make more sense. But when we're graphing an OR, I think of it as that you're greedy and you want to graph everything, because there's going to be certain situations when we do these disjunctions and conjunctions that when you graph it and you get a certain result, it's going to mean a certain thing. All right? So we're going to go over that right now.
Mr. Roy made a good point. I didn't show you guys this on the last problem, but he just said you're really graphing two different things. That's two different things. It's this, and it's also this. Everybody see that? We just graphed y is equal to 3. That's the closed circle. And then y is less than 3. That's the arrow. So we just graphed two things.
That's why we shade, that's why you're shading it in. That's why it's filled in, it's closed, because it's included. It's included in your solution set.
And that's a good point. I didn't really point that out, but that's exactly.
We're not
what
gonna make you guys write that on the test. You know, that's those two things. All right. So, like I said, when we're graphing disjunctions, we're greedy. We want to graph everything, and that'll make more sense to you in a second once I explain it. All right. So, you guys have something that looks like this on your thing, right? Don't worry about this yet. Don't worry about that. What that says down here. So we have this. So we might have a situation where we have where your inequality signs are pointing in opposite directions. Right? So you might have a situation where your inequality signs are pointing in opposite directions. So it might be something like this. All right? My arrows, there's one pointing that way, one pointing this way. Right? They're pointing in opposite directions. All right. So if I was going to graph that, let's just say I'll put something at -3 here. I'll put at 2 here. You don't have to be as, like we did before, like the number before, the number after it. You don't have to worry about too much about that now. All right? As long as I don't want to have -3 over here and 2 over here. It doesn't make sense on the number line. Right, Gage?
Yes.
Because you'll have questions on the test on Friday, and I can't really listen to you right now because you weren't listening to me on Wednesday in class. Just letting you know. Okay. So if I'm going to graph that -3, right? Corey, what am I going to do to graph that? I have an open dot and a closed dot. Open, right? How do we open here? When I do these, I just kind of imagine it first before I graph it. All right? So I got open dot here going this way. All right? Then I have this. Alex, how would I graph that? So I already have an open dot here going this way. How would I graph this, Alex?
Be a closed dot going that way.
Closed dot going that way. They're pointing in opposite directions. I want to graph both things. I want to graph open dot going this way, like Corey told me. I want to graph closed dot pointing this way. All right, like Alex just told me. All right, so it's okay. Right? So I'm graphing it, or in the inequality signs, I'm pointing in opposite directions. Again, it's an or, I'm greedy, I want to graph both lines. Right? So if I have something like this, what I want you to get the habit of doing with these guys is look at both, it's an or problem. Okay, I'm looking at both arrows, they're pointing in opposite directions. If you have to, go back to this and say, yep, okay, I know I got to graph both lines. Right? You're going to know just based on which direction those inequality signs are pointing. So if they're pointing in opposite directions, you're going to graph both lines. Right? It's okay. So we're going to get into a situation where we look at the ands, and it'll be a different situation when they point in the opposite directions. But if I'm graphing ors, opposite directions, right? The inequality signs point in opposite directions, I'm going to graph both things. All right? So So I got opposite directions. I'm also going to have get a situation where the inequality signs, they're pointing towards each other. So it might be something like right? See how they're pointing towards each other, right? So I'll say I have 2 here, and I have 5 here. So I'm going to have an open dot, because there's no line underneath, open dot here. Which way is my line going to go? To the right or to the left? To the right. That's where the arrow is pointing. So here, going this way. Then I got this. All right? I'm going to have, what am I going to put at 5? Close, because I got the line underneath. That's my hint to say, hey, make sure you shade it in. Which way is my line going to go? Right or left? Left. That's where the arrow is pointing. So if you get a situation like this, all right, open here, going this way. Closed here, going this way. When I have that, every number on that number line, because remember, we have to imagine that these lines go on forever, these arrows. We're going to cover everything.
Do you have to write it like that? Do you have to write it above it?
You can put it right, if you want, Logan, you can put it right on here too if you want.
Can you put it on the line?
Yeah, you can do that too. In this situation, every number on the number line is going to be covered. What does that mean? Anybody know?
So you guys remember the 2 special cases we did? Sometimes we had no solution, and then what was the other one?
Everything was the same.
Every,
It
yep,
was like every real number.
exactly, every real number.
All right, so your answer here would be all real numbers. All right, again, it's a situation, it's an or. Looking at my arrows, they're pointing towards each other. That means they're going to cross. But again, I'm greedy, I want to graph everything. It covers every number on the number line, because it's an or. So the answer is going to be all real numbers. That's an or when the inequality signs are pointing towards each other. So we did opposite direction, we did towards each other. What other situation could we have? So they're going opposite direction, they're going towards each other. What else could we have? Same direction. Good, Justin. So people still need this, I'll leave it up there. All right? It's like Justin has told us, same. Right? When they're going in the same direction. So I might have something like, so now they're going in the same direction. All right? Ryan, how would I graph this? I'll put my numbers in there first for you, buddy.
Put a closed dot on
Good man.
one
Yep.
and go right.
All right, so I'm going here in this direction.
Yeah.
Good. Keep that in mind. All right? Maria, to graph this, what am I doing? From what number? What kind of dot? Closed. Closed, going this way. Remember, so which line do you think I want to graph? The one that Ryan said, closed dot, going to the right, or the one that Maria said, closed dot at 4, going to the right? Remember, it's an or. I'm greedy. Which one do you think I want to graph? Do I want to graph this one, or this one? Which one do I want to show up on my graph? What do people think?
In terms of greedy, think which one would be bigger? Which
Yeah.
one would cover more numbers?
This one, right? It's exactly closed dot here. So again, if you're not sure, I mean, as soon as you get a problem that looks like this, if you have to go back to your chart, that's fine. Okay, they're pointing in the same direction. I'm going to graph the number, I'm going to graph the line that's going to be longer. That might make more sense. The one from 1 going this way is going to be longer than the 4. It's going to cover more, it's going to cover more. Remember, or we're greedy. We want to graph everything. So they're going in the same direction. Graph the line that is.
And if you guys look at that, if I said I'm going to graph everything greater than or equal to 1, doesn't that automatically also include everything greater than or equal to 4? Yeah. So that's why we did it that way. Okay, you've also graphed everything greater than or equal to 5, greater than or equal to 6. You've graphed everything from 1 up. Okay?
So you did the rest of the other page notes. Okay. Pass those on. All right, so again, greedy, think of it as you want to graph everything. Like I said, when we get to stuff we do tomorrow, the review stuff, you can, by all means, use these notes. All right? Like I said, just take a look at it and just say, okay, what kind of situation do I have? So if I look at this one, I look at this first example. Kevin, when I look at this first example, example 2A, it says graph. Again, there's no math involved here. I don't have to add, subtract, multiply, divide. It's already set up for me. The ones you'll do on the test, with the exception of one, I believe, will already be set up for you. Right? And the one that's not set up for you, it doesn't really involve any math. This involves rearranging some stuff. All right, so this one, all right, my arrows, what direction are they pointing? My inequality signs. They're towards each other, right? I got them pointing towards each other. So what does that mean? If they're towards each other, Kevin, they're pointing towards each other. Up on the notes we just took, our little chart up above. What does that mean? Which situation do we have? The one in the middle, right? So our answer is going to be what? Well, covering everything, right? Because it's an or. I want to graph everything. I'm greedy. Kev, help me out graphing this. How do I graph that? Yep. Where am I going? To the right. Good. How about this, Kev? At 1. I screw that up. Oh, this is right. And then this is going this way. I screwed that up, Miss Taylor? I feel like I did something wrong. No?
Those are going, correct.
Okay, that's all right.
It's because you have the bigger number on the left.
Oh, okay. All right. So in this situation, again, I want to. If it's an OR problem, I want to graph everything. So if I graph the 5, I'm going this way. I graph the 1, I'm going that way. It's okay. They go in opposite directions. That's okay. I'm still going to graph everything. Okay. If it makes more sense to you, if you need to, rearrange this and put the smaller number first. And then if I put that's the ones I did, I put them with the smaller number first. All right? So you guys can do that. If it makes more sense when you have it, if you want to put the smaller number first to make it work out for you, you can do that too. But again, if worst comes to worst, look at your chart. They're pointing in opposite directions. It's okay. I can grab everything. Okay? Everybody got this? Good? This one, all right? So if I'm going to do Logan, the first one, this, how do I graph it?
You put a open dot on -1,
Open at -1, going which way?
going to the
going to the right. All right, so I'm,
Gives you more numbers that it's covered.
all right, so I'm in good shape here, right? Because my smaller number is first. Right, my smaller number is in my first inequality. So I'm going here to here. Bigger numbers set. I got the bigger number second, right? Here. Which direction are the arrows pointing? They're both in the same direction. So what do I have to do? What's that mean? They're both pointing in the same direction. Graph the longer one. Which one's going to be longer? This one or this one? Y is greater than -1. I mean, R is greater than -1, or R is greater than 4.
R is greater than
All right, that's all I got to graph, right? I do it here, open circle like Logan just said, arrow going this way. All right? Because again, that's going to include R is greater than -4. That'd be here, there. Again, I want to graph the longer line. Okay? Good with this. Now this one, the first two that we've done didn't involve any math. It was already set up for you. This one, you're gonna move some stuff around. All right? So, Caitlin, what am I gonna do first? Let's do this one first. Add 5. Add 5 here. Add 5 to what else? Add 5 to the -1. Good. I'm going to bring down the 2x. I'm going to bring this down. -1 and a +5. 4. Good. Zach, now what?
You divided 2x.
Divided by 2, right? Now, am I dividing by a positive or a negative? What's that mean? Keep the sign. X. What do I get here, Zach? Multiplication. Division. Good man. Right, so that one's done. I come over here. Alexis, what's the first thing I'm going to do over here? By doing what? Subtract. -8. I'm also going to -8 from 29. Bring this down. What do I get here, Alexis? 21. Mr. Gallant, what am I dividing by?
3.
3? What's that mean for the sign?
It's going to be, it's going to stay the same
How come?
because 3 is in a negative.
Divided by a positive. Good. So I'm divided by 3. I'll get x here, I'll get this, and I'll get 21 and 3? 7. Now, am I in good shape? Can I use my chart? Am I okay to use my chart here? I'm okay to use my chart because the smaller number is in the equation on the left. If I have to rearrange it to make it work, that's okay. But my smaller number's on the left, which means the chart will work. All right? So, Gabe, what direction are the arrows pointing?
Which one?
Both of them. This one
Right.
and this one.
Left hand, right,
Are they going towards each other? Are they going in the same direction, or are they going opposite?
opposite.
They're going opposite each other. Can I do it that way with an OR problem? Can I graph in opposite directions?
Yes.
That's fine, right? Because I'm greedy, I want to graph everything. So we'll put an open circle at 2. My arrow's going to go which way? Guys? To the left. That's where my arrow's pointing. Go this way. Right? This one, open circle at 7. And Gauge, which way is my arrow going to go? To the right. Again, it's an OR problem, so it's okay if they go in opposite directions. So I'm greedy, I want to graph everything. All right? Remember, for that, if you guys understand it, you can just see it, and where things are gonna, how it's gonna work, that's fine. If you want to use the chart that we covered, all right, just make sure that your smaller number is the first inequality. So if this is the other way around, if x was less than 2 was over here, and x was greater than 7, if it was this flip-flop, you can just rewrite it and put the smaller number first. Then the chart will work every time. All right, because you might get to a situation where the bigger number might be first over here. You might have a bigger number here. right? That'll make the chart work. All right, good with this? All right, so now we get to graphing conjunctions. All right, so now here we were greedy before. We wanted everything. Now we're snobby. We only want to graph. We can only graph certain things. You know, we don't want this. We want this. All right. So with ORs, we're greedy. All right. Overlap. Well, I think, and Mr. Hager will probably agree, when you graph ORs, they're a little bit easier than the ANDs. The ANDs is a few more rules or a few more special situations. All right? Because you got to kind of pay attention to over. Because we're going to, in most situations here, we're going to only want to graph where the lines overlap. Where the ORs, a lot of times it doesn't matter. If they overlap, great. Hey, it's all real numbers. Awesome. All right? So, ANDs. We got, just like we did before, we're going to have the same situation. The first one we did for ORs or disjunctions was opposite directions. We'll do opposite direction here. Opposite directions. So if the arrows are pointing in opposite direction, if we had like x less than -3 and right, so we get a situation like this. Again, they're pointing in opposite, the inequality signs are pointing in opposite directions. All right? So I'm going to put, let's call this -3, and we'll call this 2. I'm going to do open, and we've done this before, you guys doing a pretty good job with this. Open circle here, going that way. Closed circle, because I have the line underneath, going this way. Now for an AND, we talked about that at the beginning. For an AND to be true, what has to happen? For an AND to be true, what has to happen in terms of both sentences? Both sentences have to be true. That means both sentences, in this case, have to overlap. Is there any overlap at all in these? So what do you think an answer is? Do you have one? Right, Caitlin. They don't overlap at all because it's going to be true for both. In this case, if they go in opposite direction, and it's an AND, no solution. Right, so if it's an AND problem, the lines point in opposite directions, no solution. Because there's no possible way that both sentences could be true. Doesn't work. All right? Next, we have towards, if they go towards each other. Towards each other. Let's say we had right, they're pointing, again, I have the smaller number in my first inequality, which means it'll work. So I'm going to do let's say I'll have 2 here, we'll have 5 here. If I'm going to graph this, I'm going to have an open circle at 2 going this way. Open circle at 2 going to the right. For 5, I'm going to have a closed circle going to the left. So they're overlapping. When we did an OR problem, we wanted to graph everything. That meant all real numbers. In this case, when I'm doing a conjunction and they overlap, I only want to graph where they overlap. All right? So the only overlapping in between 2 and 5. All right? So I got a open dot here going this way, closed dot here. Remember, I'm snobby. I only want to graph certain things. All right? So when I have this, I only want, it's like connecting the dots. All I want to do is graph where they overlap. All right? Only graph where lines. All right? I'm only going to graph where the lines overlap. Because those are these numbers here are my only solutions for this. Those are the only numbers that would work. Those are the only numbers that I could put in for x and have this be true for both inequalities. So if they're going in opposite directions, you only want to graph where they overlap. All right?
You mean towards each other, Mr. Lawrence?
Towards each other, I'm sorry. They're going towards each other, all right? You only want to graph where they overlap. And last one, we had same direction. Almost there, guys. All right, we're going in the same direction. Let's say I had x. Something like this. They're both going in the same direction. So when I did a disjunction and they were pointing in the same direction, who remembers what I graphed? Anybody remember? There was a disjunction and they were going in the same direction. What did I graph? The longer part, right? Because I was greedy. I wanted more. Now I'm doing a conjunction. They're going in the same direction. What do you think I want to graph? I did the longer line for a or. Logan?
Now you do the shorter.
Now I'm going to do the shorter one, right? So I'm going to put, say I put 1 here, 2, 3, I'll put 4 here. Which one's going to be shorter? This inequality or that inequality?
That inequality.
The second one, right? What's this say, Logan?
It says x is greater than or equal to.
Perfect. Close dot. Going this way. All right? So this situation, only graph the shorter line. And remember, for this chart to work, you have to make sure that your smaller number is on the left-hand side. All right? So you have the two numbers you have in your inequalities, make sure the smaller one is first for it to work. You can rearrange it, it's okay. All right? So you want to do some examples?
Does everybody get that? If I make it a little smaller, so I can. All right. So let's take a look at 3a. It says x is greater than or equal to 3 and x is less than 8. Okay, Kevin, what kind of circle would I put on 3?
Closed.
Closed, and which way would I shade?
Right.
To the right? Right. Zach, what kind of circle on 8?
Open.
Open, and which shade which way? Left. So you guys, one of you said right, one of you said left. What situation is that? Towards each other. Okay. So in that case, we're only going to graph what's in between. Okay? It's like we're going to connect the two dots. So we have to graph numbers greater than or equal to 3, but, positive 3. We also have to be less than 8. Okay, so that's your graph. Okay, this covers all numbers that are greater than or equal to 3, but also less than 8. So any question on 3a?
And we're in good shape there because the smaller number is on the left-hand inequality.
All right, so 3b, before we can graph it, we got to get x by itself. Gauge, what's my only step here to get x by itself?
-5.
Good. So subtract 5. Yep, we get x is greater than 1. And now this one we have 2 steps.
You -5 to 20, which you get 15.
Okay.
Divided by 3.
You're so smart.
Now because I divided by 3, should I flip it? No, good. And you said x was greater than, what did you say, Gage?
5.
Yeah,
5. All right. So this one says x is greater than 1. Which way are we shading for that?
Right.
Right? X is greater than 5?
Right.
Right? So we're shading in the same direction. We have to graph the shorter line. Okay. Which one would be shorter? From 1 shading to the right or starting at 5 and shading to the right?
5.
Good. So open circle on 5. shade right.
You guys are in good shape because you got the smaller number in the first inequality.
All right, and last one. Okay, let's see if we can figure out what situation this is. Look at which way you're going to shade for the first one. Look which way you're going to shade for the second one. These are opposite directions. Okay? So what does that mean when we have opposite directions?
There's no solution.
There's no solution. If there's no solution, there's nothing to draw here. Okay? We don't even have to draw anything. Just write no solution. And just think of that in your head. Try to think of a number in your head that's smaller than -2, but also bigger than 3. Is that possible? No. You can't have a number that's smaller than -2 and bigger than 3. So there's no graph we have to do. Any question on that one? All right, and last thing, okay, about conjunctions. Okay, sometimes when we have a conjunction, we like to write it a shorter way. Okay, when we have a disjunction, this is pretty much all you can do. There is no shorter way to write a disjunction. Okay, so you've got to write it like that. But with a conjunction, there is a shorter way we can do it. Okay, and I'm going to show you how we do it. Okay, what we do is we take our letter and we're going to put it right in the middle. Okay, what's our letter here? X. We're going to put the smaller number on the left and the bigger number on the right. What's the smaller number here? What's the bigger number?
4.
And then both our signs are going to point towards the smaller number. Okay, so what we just did was combine those two statements into one. This whole thing and this are exactly the same thing. Right? And in fact, if you break it apart, you can kind of see it. There's one of them. X is less than 4. That's that part right there. And then we've got X is greater than -1. That's that part right there. Given the order is switched here, but it's still pointing at the -1, pointing at the -1.
Guys, when you do that, you have to have, see, there's two different numbers there, -1 and -4. There's only one variable, but two inequality signs. When you split it, you gotta have that different, you gotta have the different number, different inequality sign, but the same variable. That's how you split it. Usually you can split it right down the middle like Mr. Hager just did.
Okay, and again, the way you read this is you pronounce it X is greater than -1 and X is less than 4. Okay, the one tricky part about this notation is you do not see the word and written. Okay, you guys just have to know if you see double inequalities, it's always an and.
Okay, let's show up on the next slide and say, oh, there it is right there.
Right? So if there's no and or written, and all you see is this, right? It's always an and statement. Think of the and as being invisible. It's right in there, but it's invisible.
But again, that happens because there's two inequality signs in that problem.
Wait, can you keep that, the writing up?
Right, there's two inequality signs in that problem. That's why it's going to be it's going to work like that. That's why it's going to be a conjunction.
Right? So without even seeing a word written here, what kind of problem do we know this is going to be? It's an and, because there's no word written. This is an and. Okay, and the way we're going to get X by itself, we're going to do it exactly the same way we would with every other inequality. Our goal is to get rid of this and get rid of that. What's the first thing here I would move to the other side?
Subtract 5.
Yeah, and the only difference is you have to do it here.
On the both ends.
Yeah, here and here. Okay, so you're still subtracting 5. Just remember you got to do it in 3 spots. What's -3 minus 5?
-8.
Yeah, -8 is less than. What's left in the middle now? 2x. And what's 9 minus 5? 4. Okay, and now my last step, I got to get rid of this 2, and I want to get rid of it in the middle, on the left, and on the right. So how do we get rid of that 2?
Divide it on both ends and in the middle.
Yep, divide it here, here, and here. Okay, so now we get x is greater than, what's negative 8 divided by 2?
Positive 4.
Negative.
Negative 4. And then what's 4 divided by 2? 2. Okay. Anytime you have this kind of problem, this is always a between. Okay, this is like Mr. Roy said, you're going to connect the dots. Okay, always. You don't even have to think about the case. If you've got the 2 inequality signs, it's always connecting the 2 dots. Okay, so what kind of circle on negative 4?
Open.
Open. What kind of circle on 2? Closed. And what did I just say to do with the 2 dots? Connect them. Okay, so for this type, you always connect them.
And guys, another way you can do it is,
So guys, we'll talk more about this tomorrow if we need to, because we only have like 30 seconds left. But your homework tonight, okay, will be on 5-4, what we did today. Okay, we'll review tomorrow, and then our test will be on Friday.